In October 2022, someone drained $114 million from a lending market called Mango, and there was no bug in the code at all. Every function did exactly what it was written to do. The attacker just made one number lie, the price of a token. He pumped it, borrowed against the fake value, and walked off with the treasury. This is Oracle manipulation, the most important attack in DeFi to understand, and we're going to rebuild it in Foundry and run it ourselves, step by step. Let's set the stage. A lending market is simple. You deposit some collateral and you're allowed to borrow against it up to a percentage of its value. Deposit $1,000 of a token and maybe you can borrow 800. The entire safety of the system rests on one question: how much is your collateral actually worth? Answer that correctly and everyone's fine. Answer it wrong, even for a moment, and someone can borrow far more than they should and never pay it back. So the real target of this hack isn't the code, it's that one number. So how does the contract know a price? It can't just look it up on the internet. A smart contract only knows what's on chain. So it uses an oracle, a source that feeds a price in. And here's the naive way so many early protocols did it. They read the current price straight from a decentralized exchange pool. That instantaneous price, called the spot price, is just the ratio of the two tokens sitting in the pool. Which means if you make one big trade and change how much of each token is in that pool, you change the price. The oracle isn't reading a fact, it's reading something you can push around. Here's the whole attack in 4 steps. Step 1, the setup. A lending market values your collateral token using that manipulable spot price. Step 2, the attack. You dump a big pile of stablecoins into a small thin pool for that token and its spot price rockets in our lab about 100 times. Step 3, the oracle now reports that inflated price, so your same tokens suddenly look worth a fortune and you borrow a huge amount against them. And step 4, you walk away with the borrowed funds. The token price falls back to reality and the protocol is left holding a pile of worthless collateral and bad debt. Let's unpack why this is so profitable. Let me make the spot price concrete. Now, imagine a shop where the price of an item is whatever the last sale was. You walk in, buy one from yourself at a crazy high price, and now the official price tag says it's worth a fortune. Then you go to the bank next door and take out a loan against your newly, quote, valuable item. That's exactly what a spot price oracle lets you do. Your own trade sets the price and the lender believes it. The defense which we'll build is to never trust a single instant. A safe oracle uses an average over time, so one fake trade barely moves it. You might ask, doesn't pumping the price cost money? Yes, a little. Shoving stablecoins into a thin pool isn't free, but that's the whole trick. The cost to move the price is tiny compared to what the inflated collateral lets you borrow. In our lab, spending $9,000 to pump the price unlocks an $80,000 loan you never repay. That $80,000 is simply gone from the protocol. Cost to manipulate, small. Value you extract, enormous. That gap is the profit. And on the real Mango, that gap was $114 million. And this really happened. This is the write-up of the Mango Markets exploit on Solana in October 2022. The attacker spiked the price of Mango's own token in thin markets, used his inflated account to borrow against it, and drained about $140 million from the protocol. What made it infamous is that the attacker, Avraham Eisenberg, publicly claimed it was just a, quote, highly profitable trading strategy, not a hack. The courts disagreed. Whatever you call it, the mechanism was pure oracle manipulation, so let's rebuild it and see it work. Here's the plan. We've built 3 tiny contracts in Foundry, a lending pool, a small decentralized exchange, and a price oracle that reads that exchange. 3 acts. Act 1, the honest path, a normal borrow at the real price works fine. Act 2, the attack, we pump the spot price and drain the pool with a loan we never repay. And Act 3, the fix, we swap in a median time averaged oracle and watch the identical attack fail. Real code, real tests in front of you. This is the lending pool's borrow function, and the danger is all in these two lines. It works out your maximum debt as your collateral's value times the loan to value ratio, and then requires that your total borrowing stays under that cap. Sounds safe. But look where the value comes from. Collateral value. Just above multiplies your token amount by oracle.price. So the entire limit is only as trustworthy as that one oracle. If the price is fake, the limit is fake. Let's look at the oracle it trusts. Here is the vulnerable oracle, and it's almost comically simple. Its price function does exactly one thing. It returns the decentralized exchange's current spot price, no averaging, no sanity check, no protection at all. It just asks the pool, what's the price right now? And reports whatever comes back. And we already know that the number is the ratio of the pool's reserves, which a single large trade can shove in any direction. This is the whole vulnerability in one line. The market price is your collateral at a number you're allowed to set yourself. Let's prove the honest path first. Act 1. The honest borrow. Read the test. We stand up the pool with the spot oracle, see the exchange so one token is worth $1, and give the lending pool $100,000 to lend. Alice deposits 1,000 tokens of collateral worth $1,000 and borrows 800. That's the 80% limit. Completely normal, exactly how the market is supposed to be used. Let's run just this test. And it passes. Read the logs. The price used is $1 per token. Alice's collateral is valued at 1,000 and she borrows 800. Honest borrower, honest price, honest limit. This is the baseline. Now let's watch the same market get robbed and see it on the Explorer. Here's Alice's honest borrow on Otterscan, our local explorer. The action is a borrow, and the tokens transferred line shows the pool sending 800 USDC to Alice against $1,000 of real collateral. Status: success. This is what a fair loan looks like. Remember it, because the attack transaction is going to look just as clean, and that's the terrifying part. Act 2, the attack. Same pool, same spot oracle. Eve deposits the same 1,000 tokens of collateral, but she also holds $9,000 she's going to weaponize. Watch the two key lines. First, she swaps that 9,000 into the thin exchange pool, which pumps the token's spot price about 100 times. Then she calls borrow for 80,000. Her collateral hasn't changed. It's still 1,000 tokens, but the oracle now says each one is worth a fortune. Let's run it. It passes, which here means the attack worked perfectly. Follow the logs. Before the pump, the price is 1 and her collateral is worth 1,000. After she dumps 9,000 into the pool, the price jumps to 100 and that same collateral is now valued at 100,000. So she borrows 80,000 and the pool is drained down to almost nothing. She turned $9,000 and a lie into 80,000. Let's watch both moves on the Explorer. First, the manipulation itself. This is the pump transaction on Otterscan. Look at the two token transfers. Eve sends 9,000 USDC into the exchange and receives a chunk of the token back. That single swap is what drains the pool's reserves and sends the spot price rocketing. Nothing here is illegal looking, it's just a trade, but that trade is the entire weapon because the lending market is about to read the price it just created. And here's the payoff transaction. A borrow and the tokens transferred line shows the pool sending 80,000 USDC straight to Eve against collateral that's really worth 1,000. Compare it to Alice's honest borrow from a minute ago. Same function, same clean transfer, status success. The blockchain sees nothing wrong because from the contract's point of view, nothing is wrong. The numbers add up using a price Eve rigged. That's oracle manipulation. Now let's fix it. This is the fix, a median oracle, the same idea as a time-weighted average or TWAP. Instead of trusting one instant, it records price observations over time, and it only lets a new sample be recorded once per period. Look at the poke function. Its price is the median of the last several samples. Now think about what that does to the attacker. Eve can pump the pool in a single block, but she can't add a fresh sample fast enough to move a median built from hours of honest prices. One spike among many normal readings changes nothing. Let's point the market at this oracle and rerun the exact same attack. Act 3. We see the median oracle with 5 honest price readings, 1 an hour, then stand up the lending pool on top of it. Eve runs the identical attack. Deposit, pump the pool, and try to borrow 80,000. But this time the oracle's median is still the honest price, so her collateral is valued at its real $1,000, and we expect the borrow to revert as under-collateralized. Then we check an honest user can still borrow normally. A good fix stops the attack and leaves real users alone. It passes, and here that means the attack finally failed. Read the logs, the spot price is still pumped to 100, but the oracle's median reports 1, the honest price. So Eve's collateral is valued at 1,000, her 80,000 borrow reverts as under-collateralized, and right after honest Alice borrows her 800 with no problem. Same attack, same pump, but the market no longer believes the lie. Let's see that rejection on the Explorer. Here it is on Otterscan. Eve is borrow against the fixed market, and the status now reads fail with the revert reason under collateralized. No tokens transferred, nothing leaves the pool. The oracle looked at her rigged price, compared it to hours of honest history, and refused. That single failed transaction is the difference between a normal day and a $114 million loss. So what's the takeaway? Your protocol is only ever as safe as the prices it trusts. A perfect, bug-free contract fed a manipulated price will hand over the vault politely and correctly. Never value collateral from a single exchange's instantaneous price. Use a time-weighted average, a median, or several independent sources that an attacker can't move all at once. The Mango lesson is that secure code is not enough on its own. Your inputs have to be trustworthy too. Most big DeFi hacks since have some flavor of this exact problem. Mango on one screen. A lending market valued collateral using a spot price read straight from a thin exchange pool. The attacker pumped that pool, the price jumped 100-fold, and his collateral looked worth a fortune. He borrowed far more than he deposited, never repaid it, and drained 114 million. The fix is one idea: price things with a median or time average that no single trade can move. Understand this one attack, and you understand the root of a huge share of DeFi hacks. If taking a real hack apart, on-chain and encoded, until it finally clicks is your kind of thing, that's this whole channel. These rebuilds take real work, so if it helped, the wallet's on screen and there's a Ko-fi link below. Every bit funds the next one. Thank you. Oracle manipulation is the attack that keeps coming back, because it doesn't need a bug, just a price you forgot to protect. If you want to actually understand how these hacks work, subscribe, because we rebuild a real exploit, on-chain and in code, every single day. Tell me in the comments which hack you want taken apart next, and I'll see you in the next one.